This is Euclid Book 10, proposition number 94. If an area be contained by a rational straight line and a fourth apotome, the side of the area is a minor. For let the area AB be contained by a rational straight line AC and the fourth apotome AD. Okay. So, the rational straight line is AC, the fourth apotome is AD, and the area AB is right here. I say the side of the area AB is a minor. So we're going to say eventually that this is a minor. For let DG be annexed to AD. We've got this, and it's going to be annexed to that. Therefore, AG and GD are rational straight lines commensurable in square only. AG and GD are rational straight lines, and the only time they're rational is... the only time that they are commensurable is when they're squared. Okay. AG is commensurable in length with the rational straight line AC set out. So, this is commensurable with this. And the square on the whole AG, okay, so that's this square right here, is greater than the square on the annex DG, which is this square right here. So this is going to be bigger than this, by the square on a straight line incommensurable in length with AG. This is by Euclid Book 10, third set of definitions, number 4. Since then, the square on AG, this square here, is greater than the square on GD, this one right here, by the square on a straight line incommensurable in length with AG. Therefore, if there be applied to AG a parallelogram equal to the fourth part of a square on DG and deficient by a square figure, it will divide it into incommensurable parts. This is by Euclid Book 10, proposition number 18. Let then DG be bisected at E. Okay, so we got DG here, it's bisected by E. And let there be applied to AG a parallelogram equal to the square on EG and deficient by a square figure. And let that rectangle be AF and FG. That's this one right here. Therefore, AF is incommensurable with FG. AF is incommensurable with FG. Okay. Let EH, okay, so we're going to draw EH, FI, and GK be drawn through points EF and G parallel to AC and BD. Well, these three lines are parallel to this line and this line. Since then, AG is rational and commensurable in length with AC, okay, since this line is commensurable with this, therefore the whole AK is rational. This plus this plus this plus this is rational. This is by Euclid Book 10, proposition number 19. Again, since DG is incommensurable in length with AC, okay, this line here is incommensurable with this. And both are rational, okay? So this is rational, this is rational. Therefore, DK is medial, okay? So, this plus this plus this, all this area combined, okay, all this area combined, it is medial. This is by Euclid Book 10, proposition number 21. And since AF is incommensurable with FG, since this is incommensurable with that, therefore AI is also incommensurable with FK. This plus this plus this is incommensurable with that little area right there. That's by Euclid Book 6, proposition number 1, and Euclid Book 10, proposition number 11. Now let the square LM be constructed equal to AI. This area is now going to be equal to this plus this plus this. And let there be subtracted NO, that's this little area right here, equal to FK. This area is going to be equal to that. And about the same angle, the angle LPN. That's this. Okay? Therefore, the squares on LM and NO are about the same diameter. Okay. So, this whole area here and this whole area here are about the same diameter. This is by Euclid Book 6, proposition number 26. And let PR be that diameter. Okay, that's this one. And let the figure be drawn. It has. Since then, the rectangle AF and FG, that's this one right here, is equal to the square on EG, which is this one right here. Therefore, proportionally, as AF is to EG, so is EG to FG. So is this to that. This is by Euclid Book 6, proposition number 17. But as AF is to EG, so is AI to EK. What is AI? That's this plus this plus this. What is EK? That's this plus this. So this area combined is to this area, the same as this is to this. And as EG is to FG, as this is to that, so is EK to FK. So as this is to that. That's by Euclid Book 6, proposition number 1. Therefore, EK is a mean proportional. What is EK? That's this plus this. And this mean proportional is between AI, which is this plus this plus this, and little fk, which is this. That's by Euclid Book 5, proposition number 11. But MN is also a mean proportional between the squares of LM and NO. Okay? This is a mean proportional between this whole area and that little square. And AI, which is this plus this plus this, is equal to this whole area here. And FK, which is this area right here, is going to be equal to this. Therefore, EK is also equal to MN. Okay. This combined is equal to this combined. But DH is equal to EK. What's DH? That's this. It's equal to this plus this. And LO is equal to MN. Okay? This is equal to that. Therefore, the whole DK, which is this plus this plus this, is equal to the nomen UVW, which is this plus this plus this. And then after we add this together, we're going to add this little square right here. Since then the whole AK is equal to the squares on LM and NO. Okay. What is AK? That's this plus this plus this plus this. All this area across here. It's equal to this whole area here plus this little area here. And in these, DK, which is this plus this plus this, that area there is equal to this whole nomen here plus this. Therefore, the remainder AB, that is this little area right here, is equal to ST, which is this little area right here. That is the square on LN. Okay? Well, what is the square on LN? That's when we take this little LN right here, we make a square out of it. Okay? So this is equal to this little square right up here. Therefore, LN is the side of area AB. This is this. I say that LN is the irrational straight line called a minor. Now we're going to say this is a minor. For since AK is rational, okay, so what is AK? This is 1, 2, 3, 4. All this area here is rational. And it's equal to these squares on LP and PN. This plus this. Therefore, the sum of the squares on LP and PN is rational. If you add these two together, that's rational. Again, since DK is medial, okay, what's DK? That's this, this, and this. All three areas together, if you combine them, that's going to be a medial area. Therefore, DK is equal to twice the rectangle LPPN. Okay, if you take this rectangle right here, you take its area, you multiply it by 2, you will get this plus this plus this. Therefore, twice the rectangle LPPN. Take this area, you multiply it by 2, and what are you going to get? It's going to be a medial area. And since AI was proved incommensurable with FK, so this plus this plus this is incommensurable with that. Therefore, the square on LP is also incommensurable with the square on PN. This is incommensurable with that. Therefore, LP and PN are straight lines incommensurable in square, which makes the sum of the squares on them rational, but twice the rectangle contained by the medial. Therefore, LN is the irrational straight line called a minor, which is by Euclid Book 10, proposition number 76, and is the side of area AB. Therefore, the side of area AB is a minor. And that ends the proof. All right. I will tell you more in a future video, so I want you to stay tuned.